All right. Everybody look at page 86. That's where I want to start. Okay. I want you to write down the definition for matrix. Okay. A matrix is a rectangular arrangement of numbers into horizontal rows and vertical columns. Okay, you will see this a whole lot. Okay, in the past, back a long time ago when I covered this, when I taught this material, I didn't really cover this a whole lot, but I have seen that you're going to see this a lot on achievement tests, on SATs, things of that nature, Algebra 2, obviously Algebra 1. They will get more complicated than this, okay? You will see it in geometry, pre-cal, pretty much every math that you're going to have from now till the time you get into college, and even in college, you're going to see matrices, okay? Matrices is the plural for matrix, okay? So most of the time you're going to see it, they're going to say matrices, okay, instead of matrix. You rarely ever deal with just a matrix because you're going to get to a point where you add. We're going to do that today. Subtract, we're going to do today. But then you will get into multiplying matrices. You'll get into dividing matrices. So you'll do all the same things that you do with regular ones, regular numbers, okay? The reason we have matrices or matrix is you can take a large compilation of numbers and manipulate them in a more succinct way than just doing them individually at one time, okay? So matrices are going to be used with large groupings of number facts, okay? We'll look at some things here in a second that will show you what I mean by facts, okay? But basically, matrices, if you look at example, the very first, right in the middle of the page, they've shown you several different matrices, okay? If you look at the one that looks like this, you have the 3, and then you have the 1/2, okay? And then you have -2 and 0, and it's in a big bracket or a grouping symbol, okay? Now, the ones they have given us here are okay, these are two equal matrices simply because the corresponding positions. Now, what they mean by corresponding positions is this. The 3 here and the 3 here. That is a corresponding position. Upper left in one, upper left in the other. Obviously, the 1/2 here and the 0.5 are corresponding positions. Okay? Lower left, lower left. All right, so they want you to see how they correlate to each other. Okay, they're different spots, different rows, different columns, they correspond. Okay, so let's move from that to look at example 2 on page 87. Okay, look at example 2 on page 87. They give you two matrices. Okay, they give us 4, 0, -5. That's the first column. In the second column, they give us 2, -3, and 1. So that's your first matrices. Then we add it to the second matrices, or the second matrix, 1, 2, and 6. And then we have 0, -1, -4. Okay? So your first matrix is one set. Your second matrix is the other set. Now, that is going to be equal, okay, that is going to be equal to adding the corresponding spots in the matrix up. So, for example, 4 and 1, those are corresponding locations in your matrix, okay? And so, therefore, my new matrix is 4 plus 1, okay? Then we're going to take the next corresponding. And I'm going to shrink this down just a little so we can get it all on the same page. The next one is the 0 and the 2. So 0 plus 2. Okay? The next one is negative 5 and 6. So negative 5 plus 6. Okay? Now we move to the second column. Okay, now we're going to move here to the second column. Okay, so that gives me 2 and 0. So 2 plus 0. Then we got negative 3 and negative 1. So negative 3 plus negative 1. Okay, then we move to the 1 and the negative 4, which means 1 plus negative 4. Okay, now we're going to come up with our final matrix. Putting the two matrix together, we come up with a final matrix of 5, 2, 1. That's in the first column. The second column is 2, negative 4, negative 3. Okay, so this matrix would be your answer. Okay, we put two matrices together, we added them. Okay, and like I said, they use matrix to take large amounts of data and combine it. Okay, you will eventually get to matrix that have, instead of just 2 columns, it may have 3, 4, 5 columns. Okay, and they use it in Algebra 2, they get very, because I had to help a young man last year, and it gets pretty complicated, okay? So we got to understand first how you, A, set up a matrix, and B, put them simply together, okay? That's the couple of things that we're looking at today. Now, let's look at an actual example, okay? Okay, now, everybody turn to page 89. Let's look at 7, 8, 9, and 10. Okay, let's look at 7, 8, 9, and 10. It says, tell whether the matrix can be added. Can you add the first one? Yes or no? And you may not know, and that's why we're doing this. You may not know. What do you think? Can you add the first one there together? Those two matrices, can you add together? Avery? Okay, you can. Let's look at number 8. Can you add those together? Michael?
No, sir.
Why?
Because there's 3 in one bracket, and then the answer is only 2 brackets.
Okay. You have, like we just said, in number 8, you have how many columns? 3 columns. The second matrix, how many columns do you have? 2. Okay. So, to be able to add and subtract, to be able to add or subtract matrices, you must have the same amount of columns and rows in each matrix. Okay? So for us to be able to put the two things together, they've got to have the same amount of rows and the same amount of columns in each one. Okay, now, let's look at the tougher one of the two. Okay, the tougher one of the two is the subtraction. Okay, tougher one of the two is the subtraction. Let's see here. Let's look at one out of the work. Let's look at number 20. Okay, let's look at number 20. Instead of looking at the example that's already done for you, let's look at number 20. Number 20, they give us the matrix of -5, -10, then they give you 11 and 4, then they give you -2 and 6, and that's your first matrix. Well, obviously, from the get-go, it's different because now I have 3 columns and 2 rows, okay? Then they're going to subtract -3, 8, 0, -5, and 2 and -1. All right, now, so here's what our new matrix is going to look like. Okay, I'm going to go -5 minus -3. Okay, then I'm going to go -10 minus 8. Okay, then I'm going to go 11 minus 0. And then 4 minus 5, -5. Okay, then I'm going to go -2. I'm going to go -2 minus 2. Okay, and then I'm going to go 6 minus -1. Okay, so now I've got to get those. Anybody not understand where I came up with that? If you do, please tell me, because I'll try to explain it. I may need to go to a board because it's obviously a fairly large set of numbers there. Okay. Larry. Oh, you have the answer. Oh, okay. Well, aren't you special? All right. All right, Larry, let's get it going here. Let me write the matrix there. What do you get the answer as? Okay, hang on here. Hang on. What did you get on the first one? 2 on that right there. So you got plus. There you go. -2 and -18 is the first column. What's the second column? 11. All right. And? Okay. Good. What's the third column? Right. There you go. All right. So that's your final matrix. Okay. Combining the two matrix, okay, subtracting them, and that's our final one. Okay, let's go back and look. Let me put in some things here. So that's plus and negative. That's plus. Obviously, 11 minus 0 is just 0. That's plus and negative, and that's plus. Okay, that's how we've come up with those matrix there. Okay? All right. Let's look at number 21. Okay, let's look at 21. Takes a little bit of thought here on 21. 21 says 3A, C minus 6, 5B, and D equals negative 12, 1, negative 5, and negative 3. Oh, excuse me. Keyboard came up. All right, now, what we want to know is, what is A, C, B, and D? What are their values? Okay, using mental math, what are their values? So what they're saying is 3A, 3 times A, ended up being negative 12. Okay, so they said 3A is equal to negative 12. So what then would A have to be? Negative 4. Okay? Because 3 times negative 4 would give me negative 12. Okay? So, A is equal to negative 4. So what is my B going to be equal to? Caleb? Negative 1. So my B is going to be equal to negative 1. Zach, what is my C equal to? Seven. Thank you. Some of us thought it was 5, but it can't be 5 because you have C minus 6 is going to be equal to 1. That's what they're saying. This and that is what they're equal to. Okay? So the only thing that C could be would be 7 minus 6 would equal 1. So that's why C is equal to 7. And then finally, the last one, which is a little simpler. Nick, what is D equal to? Oh, what is your question? On B? Okay. B said that if I take 5 times B, okay, these two, let me change colors here. That and that, okay, are the same. So 5B is equal to negative 5. So what did I do to, what does B have to be? If I'm saying 5 times B would equal negative 5, the only thing B could be then would be 5 times negative 1 would equal negative 5. Okay? And so that's why B is negative 1. Now D is real simple. Okay? D says negative is equal to negative 3. So D equal negative 3. So what's D have to equal? Negative 3. Okay? So D would be equal to negative 3. All right? So your answer to that would just simply be the numbers listed out. Negative 4, negative 1, 7, and negative 3. That would be your answer to that, to those matrices there. Yep.
Is it alright if we put the A equals negative 4, B equals negative 1, so on and so forth?
As long as you put them in order. Yeah, that's okay. But in the book, they're going to show the answer as this right here. So don't get confused. Okay? It's okay to do it like this, but the book is going to show that right there for this answer. Okay? So if you're checking your work and you look back in the back of the book at an odd problem, that's what they're going to show you. Okay? Now, let's talk about the actual writing. Okay? The writing of a matrix. Okay? How do we write a matrix? All right? Look at number 23. Okay? Number 23 says a music store inventory. Okay? A music store inventory is 52 sell price titles. CDs are okay. Then it says 3,300 or 3,300, not 33,000, 3,300 regular price titles. Okay, then it says tapes, which nobody's used in a long time. 28 sales price titles. Okay, and then 1,600 regular price titles. Okay, so what they're basically saying is with their CDs, they have 52 that are on sale, okay, and 3,300 that are not. On their tapes, they have 28 that are on sale and 1,600 that are not. So, to line this up in a matrix, okay, you want things that are the same to be listed either in your columns or in your rows. So, for example, if I want CDs here, and I want ones that are on sale here, and ones that are on regular price there. Okay? So for my CDs, that would mean 28 and 3,300. Well, I want to do the same thing for tapes. Oh, 52, excuse me. I read the wrong number. 52 on sale and 3,300 regulars. Tapes, we do the same thing. Okay? So that's one way that you could do it. You could also set it up this way. You could set it up as sale and regular, and then on top you could have CDs and tapes. Okay? If you did it that way, then it would look like this. 52, 3,300, and 28, and 1,600. Okay? What you just need to understand with your matrix, that the things that are the same, like sales, okay, would need to be the same as regular. Okay? So, look up above number 25. Okay? Look up number 25, look right above it. Okay? They have the owner of a kennel kept records of all the dogs he cares for each year. Okay? It says in exercise 25 and 26, use the matrices below, which show her records for 3 breeds of dogs cared for in 1999 and 2000. Okay? You will see how they have set that up. They have set it up as male and female on top. That's the label of your columns. And then your rows are the Beagle dogs, the Dalmatian dogs, and the Bulldogs. Okay? Go Bulldogs. Okay? Of course, we don't have any mascots that are Dalmatians. Okay? Now, obviously, firemen, their mascot are the Dalmatian, but not as colleges. We don't have any, Beagles. Hey, we're the Beagles. Well, good for you. Okay? We're the Beagles. Yeah, go Beagles. You have the Bulldogs. I don't know why they use Bulldogs. I guess, hey, it's got that Bulldog mentality. Yes, Larry. Can you what? A tissue? Yes, you may. Except they're not up there. There's one. We forgot to put them on the bookshelf. All right. So, that's how you add and subtract matrices, okay? It's how we set one up. It's how we write it, okay? So, what I want you to do is we did number 20, right? Do number 19. Do number 19 real quick. Well, not real quick, but do number 19. Do number 19 in your notes, and when you have the answer, raise your hand. We'll go over them.
Is that thing on?
All right. There's what number 19 looks like. Okay. Obviously, we've got to come up with the answer. So, I want to know if you have the first column, okay, the first column of the answer. I want to know the first column of the matrix. Zach? The first column. Okay, the first column is 2, 5, and 0. Okay? Because you had -4 minus -6. Okay? You had 0 minus -5. And then you had 2 minus 0. Or no, excuse me, 2 minus 2. I was looking at the answer. Okay? So -4 would be plus. So that would be -4 plus a +6 is equal to 2. That's where we get that 2. That would be plus. So that would just be equal to 5. That's where we get that 5. And then 2 minus 2 is equal to 0. That's where we get that 0. Okay, so what is the second column? Brandon? -2, -21, and -1. That is correct. Okay? Let's look how we got those. Make sure everybody understands how we got those. We got here, that would be, the -2 would be 1 minus 3. Okay? 1 minus 3. Okay, then we had -13 minus 8. Okay, then we had -8 minus -7. So that gives us plus a negative, so that's -2. That's plus a negative, so that gives us -13 plus -8, which is -21. Then we have plus, which gives us the -1. Okay? So that's how you get those. All right, now, here's what we're going to do. Here's the plan. First of all, Friday, we have test number 1 over chapter 1. Okay? I will not be here for this class tomorrow. So you'll have a sub. And so then if you get done with the test during class, you can start on 2.4, 7 through 28. Okay? Now, this is due on Monday. Okay, tonight, so Thursday night, after the football game, or after the volleyball game, or after cheerleading, Thursday night I want you to study for test number 1. That is your, quote, homework. Okay? So Friday you have your test. Tonight you need to study for your test that you have tomorrow. Then if you get done with your test on Friday, you'll need to start 2.4, 7 through 28. If you don't get done with your test, then obviously the 7 through 28 is due Monday, so it's homework. Okay? Okay, so one way or the other, by Monday, you need to have that 2.4 done and study for your test. Yes, Larry? No, because I didn't guarantee